Hello, happy Monday. I hope you had a wonderful Thanksgiving break. I hope you were able to rejuvenate and take the time that you wanted, be that lots of active time outside or lots of work in a kitchen or eating food or just like hunkering on your couch or whatever it is that you hoped you would have time to do over the Thanksgiving break. Those of you in the United States, I hope you were able to take that over the last couple of days at the end of last week for a much deserved and needed small break before we go whew, into the whirlwind between now and the end of the year. And speaking of now and the end of the year, it is crazy. We will be in the new year soon, which means we will be shockingly close to state testing and preparing for state testing coming forward. And so I wanted to take an opportunity today to step back and think about like, what is it we're actually asking our students to do often as they are being asked to work with data, especially as like, how do we make sense of graphs? And as we're asking them to make sense of data that are in graphs and different pieces like that. So I'm going to be sharing an example from the New Jersey Science State Test, an 8th grade example item. So in this example item, I'm going to give you the context a little bit, and then I'll show you the visualization that we're asking our students to make sense of. Students are given a figure. I'll show you that in a moment. And they are asked to look at this figure as it shows the relationship between the discovery of new oil reserves and human consumption of oil. So right off the bat, step one, we are asking our students in 8th grade, which is totally age appropriate, to compare the relationship of two different variables and think about how those two variables are related to one another. Discovery of new oil reserves, human construction of oil. And then it keeps going. The next part of the context for our students as they're reading through this test item is construct an explanation of the change in oil reserves beyond the year 2000 using the data in figure 1. And this is where our like light bulb should be flashing of we've now added a third variable because we've now added year into this. So we are now asking our students to not only age appropriate wise look at the relationship between two variables, but we are now asking for them to think about that as it changes over time. So adding that third variable of time or year into this question stem for the students. And we're asking them to construct an explanation, and they are given sort of sentence starters where they need to choose the correct answer to fill in. So with that context, let me show you what this visualization looks like for our 8th grade students. And remember, this is a New Jersey test item example for 8th graders for science. So here is the visual. Is it what you were expecting? Oh my goodness, let me make this a little bit bigger so that we can see more of this on the screen. Okay, so Nelly, there are a lot of things going on in this visualization that we are asking 8th graders to make sense of and piece apart. So let's see. Let me see actually if I can even make this even bigger for you. You won't be able to see all the pieces at once, but that's okay. So let's see. I think that's helpful. So thinking back to the question stem, we had oil and reserves. Okay. And so, or actually discovery of oil. So we look over at our primary y-axis and we see we have annual oil discoveries minus annual consumption in billions of barrels. So the question stem asked us to look at the relationship between discoveries and consumption. Okay, but now what we're actually looking at as the variable on the visualization is a difference between discoveries and consumption. So this is a delta variable. This is a constructed variable where we have taken two variables, the amount of discoveries per year and the amount of consumption per year, and we have created a new variable. This, by the way, is a very helpful thing to get our students doing and practicing as they're working with data, because we do this a lot. We collect information, but that's in its individual pieces isn't actually what we want to look at. It's the combination of the two. And so through different algorithms, aka subtraction, multiplication, different things like that. Addition, we often combine two variables of data together to get the one that we're actually interested in looking at. Okay, so first off, that's a difference between what's in the question stem and what's on the graph. Secondly, there is that need for our students to understand that this is a constructed variable, that two pieces of information have come together for this variable creation, this annual oil discoveries minus annual consumption that we have on our primary y-axis. Secondly, we need our students to be able to understand that if it is one minus the other, therefore it is sort of the difference of it, that a zero line where the value equals zero does not mean that there were no discoveries or that there was no consumption, but instead it means that the amount of discoveries and the amount of consumption was equal to one another in that given year. Now, there are no actual years where that was the case, but that's a really key component of understanding what these bars indicate. It is not the amount of, discoveries, and that's how tall the bars are, or it's not the amount of consumption and that's how tall the bars are. It is the difference, the differential between those two. And therefore, based on subtraction and numeracy skills that they have absolutely developed in elementary school. So if we give them 20 minus 10, they can tell us that it is 10. Or if we give them 20 minus 40, they can tell us it's negative 40. They can execute that numeracy 100% by 8th grade. When it comes to interpreting this graph, it means we're also asking them to make sense of the fact that when the bars are high, when they are above zero, that means there were more discoveries than there was consumption. 20 minus 10 gives us a positive number. And when the bars are below the zero for that equal amount, that means we're in the 20 minus 40 camp of we get a negative number, in that there were fewer discoveries than there was consumption. So more discoveries than consumption, more consumption than discoveries. And that's just in our first y-axis of this graph. So the question stem felt pretty easy. Okay, we're going to compare the relationship between discoveries and consumption. Now, I'm not saying that this is a bad thing to smush this all together onto one axis, into one variable. That's actually great and really good for our students to practice that. If they have had opportunities to practice with looking at a variable that is a constructed variable, with looking at a variable that is a difference, is a differential, not an actual measured value like they do often in their in-class investigations for science. We're talking about a science example here. Okay, so that's the primary y. Then we've got our x-axis, which is years. Okay, great. We knew that that was coming based on the second sentence of the question stem. And then we have our secondary y-axis, our second one, where we are looking at exploratory drilling sites in the thousands, which again could give us an indication of the amount of discoveries of oil that are out there. It's giving us some additional information as to kind of how many discoveries there are. One might see that the number of exploratory drilling sites has gone down in over the years, where we have started to move into the space where there is more consumption than there are new discoveries. So absolutely, that could be sort of a pattern that our students might see. I do just want to note that there is nothing golden about this maybe 92 or so, that is when the exploratory drilling sites happens to cross the zero line for our other axis. That is 100% dependent upon how the two y-axes are scaled. So if you are having your students look at double y-axes, this is why double y-axes are really tricky for students and adults to make sense of, is because where these two data points cross one another, our eyes naturally want to make meaning from that, seek meaning from it. And it's just not. What you need to look at is sort of the overall trend that sort of from this, let's say it's like 1982-ish to the mid 1990s, there was a decrease in the number of exploratory drilling sites. And similarly, from 1980 to the 2000s, we had way more years where there was more consumption than there were discoveries. And so those two trends across those things independently, we could then think about how they might relate to one another. Because what we're actually looking at is we're looking at annual oil discoveries minus annual consumption over time. And we are looking at exploratory drilling sites over time. And yes, we have overlaid those, but that is an extra cognitive step that we are asking our 8th graders to do. So there is a whole host of things that we are asking our 8th graders to do as they are making sense of this visualization and taking it in. That has to do with what the variables actually are, the way that it is actually constructed, and also what information we're choosing to share. Because in the question stem, we don't actually ask students about the number of exploratory drilling sites, but we are sharing that information with them in this visualization. Now, sharing extra information isn't always a bad thing, except we have to sort of think about how much are we throwing at them cognitively. One more level of how much we're throwing at them cognitively is our key, in that the key is put in here to tell us that these light gray bars are discoveries greater than consumption, and the dark gray bars are consumptions greater than discoveries, which is what we were talking about, right? With that primary y-axis being a differential. So that's in the key, that's helpful. But cognitively, we have to wrap our heads around that, right? Is it 20 minus 10 or 20 minus 40 of what we are doing to get those two different things? And by just putting it in the legend, in the key, we have to make sure we're reading the key. Reading the key is really important. But you know what's more important? Actually conceptually understanding what that means and why that is the case. Why, based on this variable, these would be discoveries greater than consumption, and these are consumption greater than discoveries. And then we have the extra double y-axis going into it. So I just use this as one example. It's got a lot packed in there. We should absolutely be showing our 8th graders a lot of data and different pieces. And then the question item actually goes on to, based on the data in the graph, discoveries of new oil reserves beyond the year 2000. And the students have to identify here, wait, let me share this again. They have to identify, does it increase? Does it decrease? Does it stay the same? And so we are looking at sort of 2000 and beyond. We're asking our students to kind of make a prediction as to what they might see in the data. Sorry for the bouncing back and forth. So I wanted to just kind of take that opportunity to take one of our question items where we're asking our students to work with data, make sense of data, and unpack it a little bit as to like just how much goes into one of these visualizations, how many different components there are, and just really call out that it's more than looking at the axes. It's more than looking at the title or more than looking at a key. It's conceptually understanding, what does that actually mean? And what information do we have that we're going on, that we're working with in the question stem, in the visualization that we're looking at. This is important for our state testing, where our students are looking at more and more visualizations, especially in their science tests. But data probability and statistics is another key part of the math state testing as well. And almost, I might say, sorry, state testing people, more importantly, helping them be able to look at any visualization that is coming their way and think about it at a level beyond just, I can read the axis labels, but getting at the like, well, what does that mean? What am I actually looking at? What was measured? What was observed? How does that relate to what information is on the graph? So, oh man, this became a long data bite. Hopefully you got some like nuggets of ideas that relate to the graphs that are showing up in your curriculum. And coming down the pike, the kinds of things that we might be asking our students to make sense of. Over the next few weeks, we're going to be sharing out different components, especially around this, like, what are our different graph types and how do we make sense of them? This was a double Y where we used a bar and a line all in one. Oh my goodness, a lot going on for those 8th graders in this. If you are interested in finding out more information about what it takes to sort of make sense of this, think about finding good data sets in your classroom. Join us Wednesday for our next upcoming monthly free data strategy share out. And if you're interested in the various components of what it takes to think about working with data at different grade levels, certainly check out our building blocks for data literacy. I'll put both of those links in the comment below. I wish you a wonderful first week of December, and I'll talk to you all next week. Until then, stay curious and have fun playing with your data.